And now we are ready to create a mesh. So let's right click on the mesh and let's go with create mesh. So here we have mesh density and we can move this to the right and to the left. So if we move this to the right, then we're gonna have finer mesh and we're gonna have more elements, and that's gonna increase the time of the simulation and that's gonna increase the memory. And here we can go with bigger elements. So this is really up to you how you're gonna set this. You can go with the default by clicking here, reset. If you open this mesh parameters, here you have some parameters. So first let's go with standard mesh here. So make sure this is checked. And here we have global size of the element. So this is 4.9 millimeters. And here we have tolerance. The tolerance is 5% of the global size of the element. And if the distance between two neighbor nodes is smaller than that, the nodes are then merged. The upper limit of the tolerance is 30%. So when you want to create a mesh, always go with the default first. So let's leave everything as it is. Let's go with reset and let's click OK. And now we have created a mesh. So if we go closer, we see that we have elements. And the perfectly shaped element will be like this. So we have 60 degrees here, here, and here, or all three lines are equal. Here, for example, we don't have perfectly shaped element. We're never gonna have perfectly shaped element, but we wanna have a good shape in the area where we predict high stresses. Since this is gonna bend, so we predict that we're gonna have high stresses here and here. So in this region and in this region, we want a well-shaped element, because then our result, stress strain displacement, will be more accurate. Now let's go to mesh. Let's right click on the mesh and let's go create mesh plot. And here we have some options. We have aspect ratio and Jacobian. So aspect ratio and Jacobian measure the element quality. So the aspect ratio is the ratio of the longest normal to the shortest normal in the element. And the normal is dropped from the vertex node to the opposite face of the element. So the aspect ratio measures how stretched out the element is, or how distorted the element is. So if we have a big aspect ratio, that means that this element is more distorted. So our goal is to have the smallest aspect ratio as possible of each element. Ideally, it would be that aspect ratio would be below 5, but everything below 10 for us will be acceptable. As well, here we have Jacobian, but Jacobian is not a graphical presentation of the element quality, is numerical presentation. And Jacobian can give good results after the simulation, and here only Jacobian predicts the quality of the element. So first let's go with aspect ratio and let's click OK. And now if you look here on the left side, we have a new folder, mesh quality, and we have mesh quality 1 aspect ratio. So here we have a legend. So our aspect ratio is from 1.53 to 9.5. So the biggest aspect ratio is 9.5. If we look closer, we see that here we have the biggest aspect ratio on this edge, because here we see how flattened this element is. If you look down here, here we have a good shaped element. And if you look at back, here are also pretty much good. And here on the other side as well, we have distorted elements. So let's go to mesh quality, right click, chart options. And let's check here, show maximum annotation. And now we can see where is the maximum aspect ratio. Let's click OK. So let's go here. And now we see that the maximum aspect ratio is here. And here, the stress result won't be so much accurate. But here are not our biggest stresses. Our biggest stresses will be here and here. So general, this would be acceptable. Now let's go to mesh. Let's right click and let's go to details. And here we have some information about our mesh. So we have a mesh type, we have element size, mesh quality, we have total nodes, 12,000, so we have over 12,000. And here we have maximum aspect ratio, 9.5. And here we have percentage of elements with aspect ratio below 3, and we have 99.7. And time to complete mesh is 4 seconds. So the number of the nodes affect on the time to complete the mesh. So we don't want to have a lot of nodes, and we want to have lowest as possible maximum aspect ratio. So let's exit. Let's go to our mesh again, right click and create mesh. So now we have a global size element 4.9. Let's go with 2.4 like this, and let's click OK. And now as you see, we have a finer mesh. Our elements are smaller. Now if we go to our mesh, right click in details, now we can see that we have 86,000 nodes, and before we have 13,000, so we have much more nodes. And the maximum aspect ratio now is 6.5, but the number of total nodes, it's not really acceptable for us. So let's exit. Let's go to mesh, let's open here, mesh quality, and let's double click on the mesh quality aspect ratio. Here, and now we see that we have the maximum aspect ratio here on this edge, not here. Here they are pretty much good. Now we have a problem here, but this is acceptable. Now let's go to mesh again, right click, create mesh. Let's go with reset to default values. Now if you notice, if you change the density, then the size of the elements changes. But let's go with default, reset, and let's turn on automatic transition, and let's see what kind of results we will get. So what is automatic transition? When automatic transition is checked, the program automatically applies mesh control to all fine details of the model. So the generated mesh is finer at the area with small features. So everywhere where we have small features, the mesh will be denser. Let's click OK. And let's go to mesh, details. And now we see that we have 15,000 nodes and 9.5 aspect ratio maximum and 3 seconds. So this is more than in the first case. Then we have 13,000 and aspect ratio about 9 something. So this is how you can create a standard mesh. In the first case, when we used default parameters, we created a mesh that was acceptable for us. But now we're going to try to get better mesh.